As we continue our coverage of performance evaluation, let's take a look at a problem that relates to operating performance measures. So get out your lecture notes and follow along. Mordecai Manufacturing keeps careful track of the time required to fill orders. Data concerning a particular order appear below. Wait time 20.7 hours, process time 1.7 hours, inspection time 0.1 hours, move time 2.4 hours, queue time 6.7 hours. So remember, wait time is what is referenced as a time from when the order is received until production begins. Process time is the actual time spent manufacturing. Inspection time is somewhat self-explanatory. Move time involves moving raw materials to the production line and then moving the units from department to department or manufacturing process to manufacturing process. And then queue time is the time the inventory spends waiting for a process to begin. So it's during the manufacturing time, just time spent waiting. Calculate the manufacturing cycle efficiency, or MCE, and explain the meaning of your answer. So here's what we were given. To determine the manufacturer cycle efficiency, you're first going to have to calculate the throughput time. That's the time spent in the manufacturing process. So sometimes it's called manufacturing time, sometimes it's called throughput time. This involves everything listed here except the wait time. Wait time is the time spent waiting to start processing, so it is not included. So if you add up 1.7 plus 0.1 plus 2.4 plus 6.7, you get a throughput time of 10.9 hours. Now we can calculate the MCE. So once again, you can see what's given there, or you can reference your lecture notes. The MCE is calculated as process time divided by throughput time. And we're trying to look at how efficient is our manufacturing process. Well, our process time, you can see there in the list of what is given, is 1.7. The throughput time we calculated to be 10.9. This will give you 15.6. Now what does this mean? This means that 15.6% of manufacturing time is spent on processing. And processing is also known as a value-added activity. The flip side to that is that 84.4% of manufacturing time is spent on non-value-added activities. So you're spending over 84% of your time moving materials or moving inventory, inspecting, waiting to begin a process, and so that represents inefficiencies. And of course, management can try to make decisions that will minimize these non-value-added activities. Next, we'll calculate the delivery cycle time and describe that meaning. We'll look at the meaning first because it helps you to understand the formula. The delivery cycle time is trying to look at how much time lapses from when the customer order is received to the time it is shipped. We were given this list of information. The delivery cycle time is going to include all of these items, all 5 of them. So if you add up 20.7 plus 1.7 plus 0.1 plus 2.4 plus 6.7, you get 31.6 hours. So this means it takes 31.6 hours from the time the order is received to the time the order is shipped. Now if we look at this list and think about what we just calculated, I want to remind you that throughput time includes everything except wait time, And delivery cycle time includes everything, even the wait time. So wait time, waiting to begin processing, is your distinguishing factor. Finally, we want to understand why we're even covering this within the context of performance evaluation. And the key here is that you want various ways of measuring performance. These provide non-financial measures. And so it adds value in your performance evaluation when you can identify areas for improvement that are not given in dollars. And they do promote efficiency. So that's the end of this problem. So as usual, bring your questions to class. See you then.